everyone, for this video we are going to talk about for our first internal test. Okay, so for the first question we are given a training data set which is D. Here you can see it, this whole training set of class label tuples randomly selected from all electronic customer database. Okay, and so the class label attribute, you can see here there is an attribute which is written as class bias computer. Now this bias computer label attribute has either yes or no, namely two distinct values, which is yes or no. Okay, therefore there are the two distinct classes. There are the two distinct classes between in bias computer label attribute. So if class C1 corresponds to yes, then class C2 would correspond to no. Okay, so there are nine tuples of yes. You can count here. There are here the yes is 9 times and the no is 5 times. Okay, and there is a root node n that is created for the tuple in D. Now for the first question we had, find the splitting criterion for this tuple using computation of information gain of each attribute. So, the expected information needed to classify a tuple is given by, you can see there is a formula how to, now we have to compute our information gain. So, how can we do that? Through this formula that is given here, where Pi is a probability of an instant of a variable in a given instant. Okay, and so for a generalized information gain, we firstly have 9 by 4, 9 by 14. 14 were the number of records, 14 are the total number of records, and 9 were the yes records. Okay, so we took here that 9 by 14. Okay, then log 2 of 9 by 14. Okay, we have taken this value, then 5 by 14, because our no was 5 times in our 14 records, and so we have taken 5 by 14 log of 5 by 10, and this value is came out 0.940 bit. This is a expected requirement. I mean, this is a generalized uh, information that has been gained. Okay. Now next we need to compute the expected information requirement for each the attribute. Now there are many attributes, right? We have age, we have income, we have student, we have credit rate, and for each and every uh, attribute we need to find their information requirements. Okay, so let's start with the attribute age. We need to firstly look at the distribution of yes. So we firstly have to take the yes, and with yes we have to find the ages values. Okay, so uh, for age category youth there are two yes. Okay, so when we had youth we had two yes and two no's. Okay, so we had here it is written there are four yes tuples and zero no tuples. Okay, so whenever there is youth there is no class C2. Okay, uh, so it is written here again for the category middle age there are four yes tuples and zero no tuples. For the category 0 there are three yes and two no's. Okay, so there are corresponding values for every yes and no with corresponding to all the values of age which is youth, middle age and senior, and for that youth, middle age and senior we had yes and no classes. So then we take that and then put them according to the formula here, we would get a value of 0.694. Okay, 5 by 14 into, why 5 by 14? Because the total number of yes and no in the youth category was 2 plus 3, as in 3 no's and 2 yes. So 5 by 14 would be the total. Then we would take account of the yes, obviously, which was 2 by 5, 2 by 5, and 3 by 5, because we have 3 no's in our tuples. Then for this was for the youth one. Then we had for our middle age one, and then finally we had for our senior category. And so with all respective to all the categories, we have added them and find a final result, which was 0.694. Here is the gain information for a partition would be, we would take the information requirement. I mean, we have generated some value, right? We would uh, take their difference and find the actual partition between them, that 0.246 was the most highest gain found among all the we have come across the information gain of an attribute which was of age. Okay, so similarly we will compute for income. Like you have here, next is income, so we would go for high, medium and low. So it would be the next uh, information gain percentage. So we would take this again, and which gave us an final result of 0.029. Then we would go for the student attribute, that which is here. Yes and no, uh, yes and no, which are the categories of student. Okay. So for the next one, we would take credit rating. Again, we will find a value from our data set here, and finally from all, and we would compare these four values, and from after comparing them we came to a conclusion that age has been the highest information gain among the attribute. It is selected as the splitting attribute. Okay, so this is how we have done the information gain. For the next question, we have find the splitting criterion for this tuple using the computation of Gini index if each attribute are given. Okay, so Gini index, how it is used for card, and how to measure it. Okay, so if to measure Gini index, we firstly have to apply this formula that is written here, which is 1 minus summation of P1 um, Pi. Again, Pi is the probability of of any instance, where now, as we know, there are 9 tuples. When we if we are talking about the first question, we had 9 tuples of yes and 5 tuples of no, and a root node of n. So again we would put all the values in respect to this formula and get a value of 0.459. Okay, so to find the splitting criterion of the tuple in D, we need to compute the Gini index for each attribute. Let's start with the attribute income. Okay, so we had income here. This one. So we would take that in the first iteration. So consider each of the possible splitting subset. Consider the subset low and medium. We had low and medium here. We have three categories, which was high, low, and medium. So we will take the first two subset of low and medium. This would result in 10 tuples partition and satisfy the condition like income belongs to low and medium. The remaining 4 tuples of D would be assigned to partition to D2. Okay, so for the next one, we would take this low and medium one and generate their own value. Obviously, because for every value, just like the information gain, we would take every attribute and calculate the value of it, just like we did in the youth one, the middle age one, the senior one. When we came across all such things, we had 3 categories, and for each and every category we had a value of our Gini index. Okay, we had information gain, at the same time when we do it in the Gini index, we would get their own values. So here you can see we had a 0.443 value. Similarly, in this way, all the values would be taken out. Okay, evaluating age, we obtained youth and youth, senior, or middle age. So for every one of them, we would take out every attribute that we have taken in this data set. And for the next one, from this we could conclude that that the age attribute has been the splitting node, as it has the largest minimum Gini index, as it has the minimum Gini index, so it would be taken as the splitting attribute. So next we have, the question was to construct this decision tree of both the cases. Now we already know, when we did the information gain, we had the value, we got a value as age. Okay, age was the splitting node that we got, and in that way only we have created our decision tree, which has age could be divided into youth. Obviously youth we have taken, then we have taken the middle age one, and finally we have taken the senior one. Youth had these three no's and two yes. Middle age has all the yes, and senior has three yes and two no's. Okay, so this way we would construct the decision tree for information gain. For the next one, which was Gini index, it is similar to the one in information gain, as here also age was the most taken as the most minimum attribute, and so we have again did the same thing. We have distributed in young, middle age, and senior, so and created our own decision tree. So in both the cases you can see that age was the factor. Okay, all in all, this was it for the video. Thank you so much.